Okay, let's deal with this. So, in terms of redox, first understand the meaning. This is for reduction, this is for oxidation, and these two reactions must occur together. Okay, so the first one is oxygen. So famous example is you take copper oxide, you react it with hydrogen. The hydrogen, because it's more reactive than the copper, will displace it. You get water plus copper. What has happened is copper has lost oxygen. So copper is correct, reduced, and hydrogen here has gained oxygen. So we say hydrogen is oxidized. Okay with that?
Yeah.
Okay. Now we can have a whole variety of these. You don't have to have oxygen there. So when oxygen is not there, we look at it in terms of electrons. So example, you do magnesium plus oxygen, sorry, not oxygen, let's say chlorine, and what you get is magnesium chloride. So this is an ionic equation. You know that magnesium has lost electrons, so it is oxidized. Chlorine has become chloride. So what we understand, chlorine gained electrons, so it was reduced. Okay with that?
Yeah.
So that's a variety. Oxidation number is an imaginary number we give when elements enter compounds. If there are elements, okay, if there are elements, example, when I say elements, I mean magnesium or sodium or oxygen or chlorine. Their oxidation number is equal to 0 because they haven't reacted with anybody yet.
Right.
Once you've reacted with something, your oxidation number is like your charge. Okay, so example, what we know is that if you get sodium chloride, sodium's charge is plus, chloride is negative, so we say oxidation number of sodium is +1, chloride is -1. We just got some basic rules. Group 1, the oxidation number is always +1. Group 2 is generally +2. Group 3 is generally +3. Group 5 is generally -3. That's your nitrogen, phosphorus.
Right, so it's 1, 2, 3, 3, 2, 1.
That's right. And if you have group 6, it's generally -2, which is oxygen,
Right.
oxide. And if you have group 7, it's generally -1. But these are not fixed. They can change. These are fixed, more or less, and oxygen is fixed unless oxygen is in a weird thing, like a pentaoxide or something like that, peroxide, sorry, and then it will have weird numbers. But normally it will be fixed. Now, if your oxidation number goes up, you are oxidized, and if your oxidation number goes down, you are reduced. Okay? Alright, we'll do an example of that. I'll take this one off
Yeah.
here. So if you do just a simple displacement, you take magnesium plus copper sulfate, you know that the magnesium is going to displace that. So you get magnesium sulfate plus copper. Magnesium here is 0 because it has unreacted. Copper is already in a compound. Sulfate is -2, which means copper should be +2 because when you add up oxidation numbers, they should give you 0. Again, if sulfate here is -2, then magnesium has become +2 and copper has become 0. So you can see magnesium's oxy number has gone up and copper ion oxidation number has gone down.
So oxidation number only appears when it's reacting with something.
That's it.
So, for example, like in this one, magnesium is not with anything. That's why its oxidation number is 0.
That's right. Okay, so if you take another one, which is carbon plus oxygen, which gives you carbon dioxide, 0, 0. Now, oxygen is always negative 2. So, negative 2 times 2, this ends up being negative 4. So, therefore, carbon must be plus 4. Because when you add them up, they should equal to.
Right. So, the oxidation number also multiplies it's O2, so that's why it's.
It has to,
right.
when you're balancing it out.
Right.
To, if there's 2 to 1 and things like that.
Yeah.
Okay?
Yeah.
So, that is oxidation number. And in terms of agents, if you are oxidized, you are the reducing agent. The most famous reducing agents we have are Ki, where it's really the I that's going to change. It changes from I negative, which is negative 1, to I, which is 0. So the oxidation number has gone from negative 1 to 0. K won't change. Because K it's group 1. Group 1 are always plus 1. And the other one is FeSO4, where Fe2 plus, which is what color?
Fe2 plus is green.
And it changes into Fe3 plus, which is
brownish red.
There you go. And that will be seen. That will be a visual. Your reducing agent, put your oxy. If you're oxidized,
yeah.
And if you are reduced, okay, pen's about to die. If you are reduced, you are the oxy agent, and the most famous is MnO4, which is from KMnO4, potassium permanganate, where it changes from purple to colorless. You got to know the color change. And potassium dichromate, Cr2O7. Again, you got to know the color change. This one is going from green to orange. So you got to know their color changes, especially these two. Okay with that? And that is basically the redox chapter. That's what you got to know. Whether you are losing or gaining oxygen, whether you are losing or gaining electrons, whether your oxidation number is being increased or decreased, whether you are an oxidizing agent, meaning you're reduced, or a reducing agent if you were oxidized.
Right.
And you got to remember potassium iodide and iron sulfate. These two very famous. Okay?
Yeah.
Alright.
Wait, so sorry, just for the oxidation number again.